Hello everyone. Today we will be solving a very interesting question. This question reminds me of questions generally asked in aptitude examinations where you have to consider all the scenarios and come up with a solution that does not contradict any of the given statements. So let's look at this question. We are given a group of n people and a 2D array statements of size n by n, which represents the statements made by them about others. There are two types of people in the group, a good person and a bad person. A good person is somebody who always tells the truth. And a bad person is somebody who might tell the truth and who might lie. So their statements are irrelevant because we do not know if they are telling the truth or they are lying. And the statements made by them about one another can be one of the following. 0 represents that the person I states that person J is a bad person. 1 represents that person I states that person J is a good person. And 2 represents that person I hasn't made any statements about person J. And no person makes a statement about themselves. And given these statements, we have to maximize the number of good people that can be in that group. So what it means is that we have to consider a scenario in which the statements made by them are not contradicting each other and the number of good people is maximized. It is also given in the constraints of the question that the number of people in the group is less than equal to 15. So let's try to understand what the statements array means. So let's take this scenario in which we have 3 people in the group and person 0 has said that person 1 is a good person. And this will be represented by. And person 0 has also said that person 2 is a bad person. This will be represented by. Similarly, person 1 has stated that person 0 is a good person. And this will be represented by. Now let's look at an example. According to person 0, person 1 is a good person. According to person 1, person 0 is a good person. And according to person 2, person 1 is a bad person. So each person can either be a good person or a bad person. So there are 2 possibilities for each and every individual in that group. So let's take the example of person 2. Person 2 can be a good person or a bad person. So let's start with the scenario in which person 2 is a good person. Since person 2 will always make an honest statement, person 1 has to be a bad person. And since person 1 is a bad person, we cannot believe whether he is telling the truth about person 0 or not. So we do not have any sufficient information to decide whether person 0 is a good person or a bad person. So we have to consider both the scenarios in which person 0 is a good person and person 0 is a bad person. So let's start with person 0 being a good person. So if person 0 is a good person, then the statement made by person 0 about person 1 should be true. So that means person 1 has to be a good person. But this contradicts our original assumption that person 1 is a bad person. Hence, this can never be the case. And hence, person 0 must be a bad person in that scenario. Hence, in this scenario, where we assume person 2 to be a good person, the number of good people is equal to 1. So now let's take the scenario where person 2 is a bad person. Hence, the statements made by person 2 are irrelevant. So we do not have sufficient information to decide whether person 1 is a good person or a bad person. And similarly for person 0. So person 1 can be a good person, person 1 can also be a bad person. So let's consider the first scenario in which person 1 is a good person. Here person 1 has stated that person 0 is a good person and this must be true. And person 0 has stated that person 1 is also a good person. Hence, both the statements support each other and they do not contradict each other. So in this scenario, the number of good people is equal to 2, which should be the answer so far. Now let us consider the scenario where person 1 is a bad person. In this case, we do not know any information about person 0. Hence, person 0 can be a good person or a bad person. But if we assume person 0 to be a good person, then in that case, person 1 is also a good person. But this is a contradiction. Hence, our assumption is wrong. Hence, person 0 has to be a bad person. Hence, out of all the scenarios, the maximum number of good people is 2. Hence, the output is 2. Okay, so you might be wondering, how do we come up with a general solution for this question? And to be honest, there is no easy way to think about this type of problem, especially if you have never seen them before. So let's consider that we have 3 people in the group. So each person can either be a good person or a bad person. So there are 2 possibilities for each and every person in the group. So there should be total 2 into 2 into 2 is equal to 8 different types of possibilities. Okay, so these are all the 8 possible scenarios where a person can be a good person or a bad person. So this is very similar to a binary representation of a number. For instance, the binary representation of 2 is 0, 1, 0. Hence, for n people, the total number of combinations has to be 2 raised to power n. Hence, this gives us a clue to proceed with generating all the combinations of our possible scenarios, where 0 might represent a bad person and 1 might represent a good person. For any given n, the combinations will be in the range from 0 till 2 raised to power n minus 1. And for each of those combinations, we have to find out if our assumption is valid or not. If there's a contradiction, then our assumption is invalid. So now let's look at an example where out of 7 people in the group, person 1 and person 3 are good people and the rest are all bad people. Now we have to validate if our assumption is valid or not based on the statements given by the good people in the group. If there is any contradiction, it means that our assumption is invalid. So now let's look at the statements given by person 1. He has stated that person 0 and person 2 are bad person and person 4 is a good person. So now let's check if there is any contradiction or not. He has stated that person 0 is a bad person. And we can see that it is indeed the case that person 0 is a bad person. Hence, there is no contradiction. He has not made any statements about person 1. Hence, this is valid. He has stated that person 2 is a bad person. We can see that person 2 is indeed a bad person. Hence, there is no contradiction. He has not made any statements about person 3. Hence, this is valid. He has stated that person 4 is a good person. But in our original assumption, person 4 is a bad person. Hence, there is a contradiction over here. Hence, our assumption is invalid based on the statements. Here, a person whom we had assumed to be good has stated that a bad person is a good person, which is a contradiction. So this is the first type of contradiction that can happen. Here, a good person has stated that a bad person is a good person. So now let's look at another scenario. Here person 1 has stated that person 0, person 2, person 3 and person 4 are bad people. Now let's check if our assumption is valid or not. He has stated that person 0 is a bad person, which is indeed the case. He has not made any statements about person 1, hence this is valid. He has stated that person 2 is a bad person. This is indeed the case. He has stated that person 3 is a bad person. But according to our original assumption, person 3 is a good person. Hence, this is a contradiction and our assumption is invalid. Here, a good person has stated that a good person is a bad person. This is our second scenario where a good person has stated that a good person is a bad person. So these are two different types of contradictions that we can find on our assumptions. These two conditions might seem a little confusing at first, but you might have to go through this video again to fully understand it. And for each of the valid assumptions, we have to count the number of ones set in it. And we have to keep a global count to find the maximum of all the valid assumptions. Time complexity would be, we have to generate all the different combinations and then check all the different statements. Hence, the time complexity would be O of 2 raised to power n into n square. And since we won't be using any different data structure, our space complexity would be constant. The solution that we discussed right now is also a pattern that can be used in many different problems. And this pattern is called as bit masking. This pattern is generally used in problems where the constraint is very small. For example, in this case, the constraint n is less than equal to 15, which is given in the problem itself. Hence, we get a clue that we can brute force our solution. Here we generate all the different permutations and combinations and then check if it is valid or not. To find out all the good people in the group, we have to find out all the bits that are set to 1. To check if the ith bit is set in a number or not, we could right shift by I times and then AND it by 1. The right shift operator would bring the ith bit to the 0th position. And when this is AND with 1, it would give us 0 or 1. If it is 1, that means our bit is set, else it is not set. Or alternatively, we could left shift 1 to the ith bit and then AND it with mask. This would result in either two values, 0, which means the bit is not set, or if there is any other value, that means the bit is set. Let's implement the solution. Let's create a variable for the number of people in the group. And let's initialize our answer to 0 because in any case, if no people are good, then our answer 0 will still be valid. Now let's initialize our bit mask. Here I am running a loop from 1 to 2 raised to power n minus 1 because I don't really have to check 0 because in any case, right, the answer in that case, since no people are good, the answer would be 0 and that's already covered. To generate 2 raised to power n, I am left shifting 1 by n bits. This is absolutely same as 2 raised to power n. And now we would write our standard bit masking code where we have to validate each and every statement from our bit mask. And if it is valid, in that case, we would have to update our answer. This part over here would count the number of bits that are set. Hence, this would give us the number of good people in our mask. And now let's write our helper function. We receive the mask variable inside it. And now we have to find all the good people in our mask. So now let's check if that person is a good person or not. So now let's create the helper function checkGood where we receive the person and the mask. So we can check if that person is a good person or not by right shifting or mask by person bits and then ANDing it with 1. If it is not 0, then that means he's a good person. Else return false. This part could also be written as left shift 1 by %bits and it with mask. So now we are done with our helper function, and if that is a good person, then we would have to validate his statements and make sure that it does not contradict our original mask. Hence, we would retrieve all his statements, and since he would have made n statements about n different people, we would start a loop. Here j represents the person on which person I has made the statement. So let's look at that statement. So now let's try to find contradictions in the statement. There can be two types of contradiction as we had discussed. The first contradiction is when person I has stated that person j is a bad person, but person j is a good person according to our mask. And the second contradiction could be when person I has stated that person j is a good person, but person j is not a good person according to our mask. We have checked that person j is not a good person using the not operator. And if we find any contradiction, then we could directly return that our mask is not valid. When we have gone through all the statements by all the good people and yet we haven't found any contradiction, in that case we could return true, that our mask is valid. And now we could directly return our answer. And now you could see that our solution is accepted. If you have any concerns about the solutions, please leave a comment. If this video was helpful to you, please leave a like and subscribe to the channel. Thanks for watching.